I'm going to commit that I'm not going to use maths which is grade 5 or grade 6 maths. Anything above grade 6 maths, if you ask me any question, I will say I don't know. What are you talking about? So what does that mean? It basically means make sure that you really understand that 2 times 2 is equal to 4, 2 plus 2 is 4, 2 divided by 2 is 1, and 2 minus 2 is 0. If you are comfortable with those 4 algebraic operations, that will be good enough for this course. Because I'm discounting all of this maths and everything, what should I do here? I'm going to put a lot of real-world example. The real-world example that will understand the concept. Here, my job is the theory. You don't need to know the basis of the theory. You need to understand the interpretation of the theory, right? And how does that help or fit in the real world? That's what I'm going to do. So sometimes I call it the dual personality, because if you go back to my research, it's full of maths, but when I lecture, I don't use any maths. And in the exam, I will try to minimize that maths as well. So don't be afraid, don't be scared, right? So that's the first thing. The second thing is, I really apologize. Generally, this is a large class and we have 2 or 3 lecture classes, right? But what happens this time, there's only 1 lecture class allocated for mpe781. Why? Because they told us that we have a problem, the classroom shortage. There's a lot of construction and innovation, renovation is going on, and therefore we have a classroom shortage for temporarily. So what they did, they lumped all the class in one. So I know some of the students that I have has a clash with other classes. And I'm really sorry for that, because at this stage I have no power to control, right? Now you can go for cloud, but you know, face-to-face and cloud is up to you, where you feel comfortable, right? I can't force you. So what I'm going to do, lecture 3, so Thursday 12 to 3 is a lecture class. You'll go through me with these slides, try to understand the concepts, right? Then every Sunday in the morning, 10 o'clock to 11, I will make an announcement soon. I'm going to run a Blackboard session. So what is the Blackboard session? This is a virtual classroom. In the Blackboard session, remember, at the end of each lecture slides, you'll find some problems. Every week, I put some problem set. These problem sets are very important. Why? Because your final exam questions are very similar to problem sets. So if you feel comfortable with those problem sets, you'll be okay with the final exam. In the Blackboard session, I'm going to discuss those problem sets. So what will I do? I'll first explain the relevant concepts. Then I will show you step by step how you solve the problem, right? You find me, I'm drawing a picture there, little bit algebraic operation, 2 plus 2 kind of thing, right? And then derive the result so that you understand what is happening there. So how do you follow this thing? First, follow the lecture slides. Second, before you attend the Blackboard session, make sure you go through the lecture slides and the relevant concepts in your textbook. Then try to attempt those practice questions by yourself. Remember, I already posted the solutions there. Once you attempt the practice questions, you find that a lot of questions arise. We have a problem there, here, and there. Attend the Blackboard session. Then those problems will be clear, right? This is how you need to prepare yourself. Now, are you familiar with the cloud decking environment? So every time, check the news. I'm going to post a lot of news here and there. So at the moment, the most important news is your assignment question is already posted. Have you checked that? It is the online shopping tax on Amazon.com, right? And that will be affected from the 1st July of this year. So what will be the consequences there? Now, did you know that if you go to the Amazon.com, the international site, you have been already blocked? In a sense that they will say, we are not delivering you to Australia, but any US address will be fine. That happened after 1st July. One of the reasons is because our government decides to tax them. These are the multinational company, and they evade tax. So we said, okay, we're going to tax them. And the Amazon, this is a dominant firm in the world, so they retaliate. Okay, You tax them, fine. The international side, we will say, okay, we are not going to deliver anything to Australia. If you want to buy something, you go for amazon.com.au. Now, if you look at that thing, you'll find there's a price discrimination there. The same good, amazon.com.au, bit pricey, but amazon.com, even though you added the, the postal fee and all those things, price is much cheaper, right? And the article is all about, this is a hot topic at the moment in Australia, not just in Australia, all over the world, right? How we control the multinational companies. Do we tax them? Do we create an entry barrier? How does that help the local competition and all those things? So please go through those articles. Try to understand the concept as well. On week 3 or week 4, I'm going to also allocate 15 or 20 minutes in my lecture class to discuss thoroughly about your assignment question. Now, you're not expect me to answer all the questions, because if I answer the question, I'm correcting the question, that would be conflict of interest. But I can show you the direction. What does that mean? Where you should dig the resources, how you answer them, these sort of things. Basically, open up your eyes, right? And please do that thing, because this is a hot topic at the moment, okay? Any question? No? Now, different lectures has a different style. I don't like to be a formal. That's my style. So every time you'll see that I will ask you a lot of questions, right? Rather than go through by slide and line by line, because that's absolutely boring. If you go through the cloud deck, and you'll get it. So why I'm going to follow the same line again? Some of you, if I'm in your place, I will go to sleep straight away, right? So I don't want that kind of outcome. What I will do, I will ask you a lot of questions. That does not mean that you know all the answers. Whatever you think, whatever your reasoning, you answer those questions. There's no right or wrong answer, right? But if you come up with the good logic, that's what we are looking for. Argument with good reasoning. Is that clear? Okay. So let's start with this. So today we are going to cover the Introduction to Economics, mpe781. And this is a core course, right? So you need to do that thing. If it's an optional, it's up to you. So I just go through the first one. Another important information that I should remind or tell you is the online discussion folder will be discussed or answered by Shurjo. He's our second-year PhD student. He's a very promising second-year PhD student. He's going to answer them. And we also put his phone number. So at the moment, the department is organizing them. So he already put his consultation hour on Friday 4 to 5. So if you ring on that number, once the department set up the numbers, he will be available to assist you. On top of that, we have a math tutor. Her name is Marve. She did her undergrad in mathematics. Now she is our first-year PhD student. Now she's available on Monday from 1 to 2. If you ask or ring her, she will help you for your maths, right? Because sometimes, even though it's a year 6 or grade 7 level maths, we did a long time ago and we forgot, right? For example, if you have a multiplication and division and then you have a square bracket, which one will go first? We forgot, right? So Marvi is going to help you on that respect. So you have a math tutor, you have economics discussion folder, that is the economics tutor. On top of that, I'll be available on Tuesday from 11 to 1. Feel free to come to my office, or you can ring me, whatever you like, right? As long as you find me, I'm in office, just drop by. You don't need any appointment for that, right? Okay. So today I'm going to talk about this thing. So these are the topics that I'm going to talk about. What is economics, assumption of the rationality, micro, macro, methodology of economics, economic resources, some technical aspects. When I say technical aspects, these are the building blocks of our 11 weeks lecture classes. If you are comfortable with those technical aspects, that basically means you'll be okay for the next 11 weeks. I'm not going to introduce any new concept, right? So make sure you go through that thing. So opportunity cost, production possibility frontier, and finally, how we use the production possibility frontier, in particular, the basis of trade, which is the comparative advantage theory. So we already know, I can see that some of you know the textbook. It is the customized textbook, mpe781 Economics for Managers. And the chapter that I'm talking about, extract 1, 2, and 3. These are the relevant chapters for this slice. Any question? Okay. Now, these are the slice talk. So you can see that I just follow the slice. Now I come back to the real world. So if I ask you, what is economics? What is the first thing that comes to your mind? What is economics all about? Sorry? You really go through this slides, right? Anything else? Yeah, but basically why you do the allocation of resources? Because she says it's scarcity, right? That's why it's coming. Demand and supply? Understanding. So basically he's talking about the same thing. Demand and supply is the basis of the market. So when you say understanding the market, you have to go through the demand and supply. Yeah. Anything else? No idea? Sorry? Prioritize your demand or prioritize your choice? I mean, when you say demand, I think you mean choice, right? Prioritize your choice. Now, all of you are talking are absolutely right to some extent, but these are slice talk. You are not talking from your real sense what you mean by economics. You go through my slides and you're answering some fitting up with these things. Yeah? Again, the same thing, right? Now, here's I'm going to tell you. First of all, when someone says economics, take my word. I've been studying economics since 1992, right? So it is absolutely boring subject. No doubt about it, right? And that's the first thing you should understand. Second thing, when you say choice, scarcity, you're not talking about the thing that economics do, right? For example, I fall in love and I want to get married. How does the economics help me in that respect? Now, how does market concept help me? These are the real world issue, right? Believe me, choosing a partner is not an easy thing. Now I'm asking you, how does the economics help me? If you understand that concept, then you pretty much understand what the economists do. Really? If I'm a billionaire, do you think I'll get my soulmate? Or I get someone who likes my money? I'm looking for my soulmate, right? Not the other thing. Yeah?
So you will go for the marriage shopping at the right time?
What is the right time? Again, the problem remains. Sorry? Really? When you fall in love, you start to calculate what is my pros and cons? Believe me, I've been married for 11 weeks. If I do that, oh man, my life will be hell. Right? Now, remember, economics, whenever someone says market, generally we go for buyers, sellers, demand and supply and all those things, right? That's our understanding about the market. Economics is not about that. The definition of the market, economists put in a different way. What it does, they call market is an institution. When I say institution in economics language, it means a set of rules, right? Now the question is, what does this institution do? It actually processes the information. For what? So that exchange will take place, right? And that's called a market. Now I come back to the marriage. I'm looking for my soulmate. So what we should go through that thing, whether you go for arranged marriage or go for dating, what you are doing in this case, you are actually processing information. You have some set of rules. You're looking for a soulmate in a sense that your set of rules will be satisfied mostly. That's how you find your soulmate, right? Whether your parents do that, in that case we call it arranged marriage, or you do it by yourself, that's a dating thing. But the purpose is the same, processing the information. Once you find the soulmate, you enter yourself into committed relationship, whether it's a marriage or living together, whatever it is. But that also means your exchange is taking place. Clear? In that respect, marriage itself is a market. So when you say market, it's not just a buyer and seller. Always remember, the processing information, that's the one part, and the second part is exchange is taking place between the two parties at least. Gary Becker in 1980s, who come up with this concept, using the market concept in marriage and dating money and all kind of thing. And remember, later on he got the Nobel Prize for that. Now this theory is heavily used to analyze the custody law, divorce law, and also the marriage market all over the world. So you see, when I say economics, it is actually more than buyers and sellers. And this is what you need to know, how we apply in the real world. The most important one here is the marriage market. Does it make sense? Okay. Now, in my slides talk, when I say that, look at this, I say economics is a science of choice. Why? Can it be science of something else? Science of boringness or science of something else? Rather than choice, why we say choice? One of the important thing is, when you look at the world, our resources or budget, we have a limited budget. That means we have a resource constraint. If you enter in a job market, your salary cap is there. Remember? That's your budget. You cannot exceed that budget. When your budget or resources are limited, you are constrained or forced to make a choice. What does that mean? If I have a limited resources, I cannot have everyone to satisfy, or every wants that I want to satisfy. I cannot do that. Do you agree? So that basically forced me to make a choice. So now it says, look at this, making a choice and problem of scarcity. Where does this scarcity come from? Because we have a limited resources. And because we have a limited resources, we always face a trade-off. If I want to attend this lecture class right now, that basically means I'm giving up my sleep or work or enjoying the movie. Right? Sometimes we call it opportunity cost. The alternative that you are giving up to do something else. Is that clear? So that's what we are talking about. Now, I'm going to ask you a question. Suppose, I'm making an assumption. Economists love to make an assumption. So I make an assumption, I'm very religious and I'm dead. So I enter into heaven and I do my job as an economist. Do you think I have a bright prospect in heaven? Very simple question. Now that you know what the economist does, do you think I have a good prospect in heaven?
No.
Why not?
Because, according to...
That's a right answer. Yeah?
According to the, Bible and all things, we are, making a choice and, we are looking for the profitability and all that, regardless of any,
Yeah, how does my profitability affect? Can I do any arbitrage in heaven? Suppose I'm a very cunning economist. I'll always look for an arbitrage. Can I do that? Arbitrage opportunity, actually. Here's the thing. She answered the right one. If you go to heaven, by definition, everything is plenty. When I say plenty of everything, there's no scarcity. If there's no scarcity, you don't make a choice. All you need to do, just make a wish. So one thing I can tell you, all those bunch of economists becomes unemployed in heaven. That's for sure. Can you understand this concept? So basically, that's why we said the economist is a science of choice. So now I'm going to summarize again. I think that having an example will be really good. You understand now? The economist is a science of choice. We make a choice because we have a scarcity of resources. When we have a scarcity of resources, you cannot have everything that you want. You have to face a trade-off. If I want this, then I have to give up something else. Right? So then the question is, I have to make a choice. Now, what does the economist will do? It will help you how your choice or whatever choice you make will be efficient. Right? That's why we need to understand, when I say efficient, it is the thinking at the margin. I will come back to later what is that thinking at the margin, right? So we need to understand that. So it is a science of choice. We make a choice because of the scarcity, and more importantly, now it boils down how we make an efficient choice. Clear? So that's what the economists will do. Now look at this. They're talking about maximization. Of course, if you want to maximize your satisfied, that means you'll be very happy, right? If you want to maximize profit, then as a farm, you'll be very happy. As a government, you want to maximize the welfare, right? So we are maximizing something here. Or the opposite of the maximization is the minimization. What is that? Minimization, the cost, right? Either way, you need to learn those things, and we will cover that thing when we cover at the margin. Now, maximization problem, minimization problem, all these will do to make your choice efficient. So what does that mean? I will make a choice so that it will maximize something, whatever my objective is. If it does, then I will say my choice is efficient. Clear? The most important thing is, before you make a choice, we also make an assumption about the rationality. So what is the rationality means here? Of course, when you make a choice, you need to be very reasonable, right? So suppose I prefer X to Y. Then I say I prefer Y to Z. Then transitivity rule dictates I prefer X to Z. Right? So what does that mean? Suppose there's 3 girls, right? Don't be offensive. I'm just giving an example, right? A, B, and C. I prefer A to B, B to C. Then by logical deduction, it also means I prefer A to C, right? But what if I say I prefer A to B, B to C, but C to A? What will happen then? There's 3 beautiful girls. One is named A, another named B, another named C, and I say, okay, I prefer A to B. So A is my first choice when it comes alternatives A and B. Then I say, when it becomes B and C, I actually prefer B. But when it comes C and A, I actually prefer C. Now, can I make any rational decision? Basically, you are creating your own loop, right? What will happen, anything you choose, you always end up with that loop, right? So sometimes we say that when this thing happens, you cannot make any rational decision because it broke the intransitivity rule. So this is one of the example of the rationality, but now I will go through more of these things. When I say rationality, what does that mean? So in economics, when we say rational, these 3 things we mean. Consumer is rational because he's maximizing or she is maximizing her utility. Producer is rational because he or she is maximizing her profit. Government is rational because government is maximizing the welfare. In that sense, they are rational, right? Now, if you ask me, Nobin, is it really definition of the rationality? I will say, look, this is definition based on the narrow sense. In reality, the rationality is a very subjective thing. What you think is rational, I might not think is rational for me. Right? For example, have you heard emperor named Genghis Khan? Right? Do you know his life history? Some of it. Genghis Khan got married. Right? And when he got married, he wants to take his bride to his house. In the middle of that road, he was attacked by heavily armed 20 people. Now, he has 2 choices. Either he can flee away from there, leaving everything behind, or he needs to save his wife. Now, remember, this is newly wedded wife I'm talking about, right? What would be the rational thing to do? Sorry? Flee away with wife? Either I flee away from that thing and save myself, or I save my wife. Save myself? Oh yes, From that side, you can tell. If I tell this thing to my wife, next 2 days is out of the question, right? Okay. The rational thing, again, is a subjective thing. You don't know what to do, right? So if you put in my side, I'll probably say, I'll save my wife, right? Show my love and all kind of thing. But Genghis Khan did not do that. He simply fled away from that place. He says that only the fool will fight against those heavily armed 20 robbers. You'll be dead no matter what. After 1 week, he grouped his army, came back, killed them all, and rescued his wife. That's what he did. Now, you see, the rationality, it actually depends. That's why I say it's a very subjective thing. Now, even though I said that the producer maximizes the profit, think about the business owner. Most of the business owner, or the family business I'm talking about, they actually employed the family members. And if you look at carefully, these family-owned business are overemployed by the family members, which means they are not minimizing the cost. If they are not minimizing the cost, that also implied they are not maximizing the profit. Now tell me, are they rational? Well, according to this definition, no. But if you look at the broader perspective, you need to think about what is their objective. Their objective is to maximize the well-being of the family members. I want to give an experience to my family members so in the job market they do very well. Right? If that is the case, then they are rational. Clear? So whatever I'm defining here, it is only for next 11 weeks. And as I said, it is the limitation of this definition. But we will stick with that. Is that clear? Okay. Now let's see what it is. Oh, it's coming. That's good. Look at this video carefully and tell me why he did that. This video is taken from the Pirates of the Caribbean. You know, the Jack Sparrow and all those things. So, yeah.
Hold up there, you. It's a shilling to tie up your boat at the dock. And I shall need to know your name.
What do you say to 3 shillings? And we forget the name.
Welcome to Port Royal, Mr. Smith.
Okay, what do we learn here? First thing is, he sank his boat. Can you see that? His ship, basically. Right? And he walked away from that thing very quickly. What is the rational explanation of doing that? We are talking about the rationality. It's okay.
He's getting rid of his loss.
Okay. Really? So I sink my ship, and you are asking me, I'm not blaming for something. What are you talking about? Anyone else? Sorry? Well, what? I'm hiding of what? Okay. Really? Now, I'm talking about the rationality here, right? In economics, there is a concept, it's called a sunk cost. Jack Sparrow realized he cannot save his boat, no matter what he does, right? That means he cannot save his ship sinking in that ocean. It will happen no matter what happens. Now, if that cost involved, we call that cost is a sunk cost. It is sunk in a sense, he cannot recover it. It is unavoidable. Then what is the rational thing to do? Quickly get over it. Go back, do your own thing. This should not affect your choice-making process. This is exactly what he did, right? Suppose I bought a movie ticket, and I want to go with my wife and enjoy the movie, and at some point I lost my movie ticket, right? I search for it, and it turns out that I cannot recover it. Now, that movie ticket cost me, say, $40. In economics, now we call it as a sunk cost. So if you really want to make a decision, and provided that you can afford it, this sunk cost should not affect your decision-making process, right? So what is the important thing here? You get over it, right? And focus what you want to do. Clear? So that's the important thing. So look at this. They give us an explanation here. So there's a couple of explanations. Why doesn't Jack care that this ship sank? And what is the opportunity cost of sinking ship? Captain Jack Sparrow's ship is sinking and he doesn't seem to care. A poor explanation, like all of you did, for his behavior is that he stole the sinking ship. This is true because opportunity cost ignores the historical prices. If Jack paid, I don't know how to go in this way. Okay. Where am I? Okay. If Jack paid 0 for ship, he's still losing whatever he could have sold the ship for, right? The better explanation is, when Jack realized that his boat was going to sink before he got it to shore, he immediately realized that it was out of his control. So, in other words, he got over it quickly. He realized that this sunk ship would be a sunk cost. Sunk cost can never be recovered, so he decided not to worry or fret about it too much, right? So more about sunk cost after this jump. If you recognize this article, then please go recognize. So basically what I'm saying here, this is also the rational thing to do. Once you realize that you cannot recover these things, there's quickly get over it. You cannot recover that thing, right? Focus what you want to do, right? That's also the part of rationality. Does it make sense? Okay. So generally what happens, some of these students, last year when I was delivering the lecture, they says, oh, I broke up with my girlfriend, I cannot submit my assignment on the due date, and can I get an extension? Now, my answer to that is no. Well, if you broke up with your girlfriend, that didn't happen in one day. And the assignment, I already posted on week 1, so you should know what you want to do, at least in this class, right? And more importantly, this will be a sunk cost. You quickly get over it, focus what you want to do. Clear? Does it make sense? Okay. Now, there's a micro and macro economist. So what is micro and macro? Always remember, the economist, there's a two-part of it. One, micro, when we focus on the individual agent's behavior. So I want to know, as an individual producer, how he behaves, right? I want to know, as an individual good, say for Apple, how the Apple market behaves. So it is the individual goods behavior, right? Goods market behavior. When you focus on an individual entity, we call it micro. It's a very simple, small one, right? Macro, we are looking for the bigger picture. Now we are not looking for an individual agent, but we are talking about the country. In the country, there's a large number of individual producers who are working. And I want to know how they behave at the aggregate level, right? To some extent, there is an idea, they call it micro-integrated macro approach. The basic understanding is, if you understand the individual agent's behavior, and provided that more or less every individual agent has the same preference, then you can predict what will happen at aggregate level. Do you understand that part? So basically, suppose we all are economics students, and we say that, okay, one of these students prefer, say, what do you call? Vegetable, say for example. It's good for health, they like it. And I'm assuming that the preference more or less the same. That means all these students' preferences are the same. Therefore, at aggregate level, we know that majority of them actually like. Now, this is basically talk micro level, which is the individual student. Then I'm focusing the macro level, what the class wants. Right? So the idea is, if I understand how the individual producer behave, then I can know in this country, provided that their preference doesn't change, and provided that we operate with under the same institutional rules, then we are almost the same, then I can predict what the country will do at future. Right? This is why we need micro and macro. Unfortunately, I'm going to give you bad news. What the bad news? The macroeconomists are not doing their job. Who are the macroeconomists? Those who are talking about the RBA's policy, that means central bank's policy, interest rate, or the inflation, or the unemployment, right? These are the macroeconomists because these are the macro variables. We are talking about the GDP growth rate, how the economy will perform, and all kind of things. But I'm telling you, these economists are not doing their job. Why? Have you heard GFC 2008? Global financial crisis 2008 that took place, right? How many financial crises took place before that? At least 14 or 15, right? The biggest one is the Great Depression in 1929, around that time, right? And the second biggest, they says, is the GFC 2008. In between, 1974, there's one recession. 1984, there's another recession. There's a oil price shock. Again, the recession came, and all this thing happened. Now, every time the recession took place, these economists, the bunch of economists says, oh, the lack in confidence. That's why it took place. Have you heard that term, lack in confidence? Investor has no confidence to invest, right? That's why the demand goes down and the economy is falling, right? Now, here's the thing. Every time the recession took place and you said the same thing, what does that mean? One thing, you have absolutely no clue what is happening. If you know, then you will not say this is the cause. So that actually reminds me, the behavior of the economists and the medical doctors, they have some similarities. When the doctor has no clue what causes fever, they say it's a viral. Right? And when economists has no clue what causes this recession, they always say lack in confidence. But here's the question, if you really understand the lack in confidence, then why not you fix it so that we never face the recession? That never happens. They take a lot of policy, but it just keeps coming. So in other words, there's a joke. These macroeconomists, they make a bigger mistake, and all the bunch of microeconomists, they make a smaller mistake because they deal with the small agent, right? But the bottom line is, they all make mistakes. So if you really understand the economists, don't go through the textbook or don't listen to what the economists are saying. One day you'll find that ANZ Bank says, oh, the interest rate should go down. The next moment you'll find that RBA economist says, no, interest rate will be fine. At the end, what will happen? You'll be highly confused. What's going on here? Right? So here's my thing. If you really want to learn economics properly, and you behave like an economist, then the best way to do it, try to understand how to confuse people in a very good way. If you do that, you'll be a very good economist. Right? Okay. Now, I'll just go through the micro and macro. Now I need to show you how the economists work. First, they identify the problem, right? And the second thing they do, they try to get the relevant variables, model intuitive, graphical, and mathematical. So they put all those things together. And then finally, they test the model. That's what they do, right? So this is how the economists work. So when the problem starts, say for example, the recession problem starts, they try to identify what causes the recession, right? Then according to this model, they figured out lack in confidence, that's the one that causes the recession. It is true to some extent because the investors have no confidence about the economy, so they hold up their investment decision. What does that mean? There will be no demand for jobs, no demand for goods, the economy is diving down, right? So obviously this is a problem. So lack in confidence is the problem. The second thing is you develop the model with relevant variables. So basically now you try to understand what causes the lack in confidence. What are the appropriate variables? And you come up with a mathematical model or the verbal argument. We call it intuition, right? What causes that? And once you've certain that X causes Y, then you test your model, gather information about X, and find out whether X and Y has any relationship. Right? Now, how does that affect? The first two parts, micro and macro, we are actually trying to understand the relevant variables, the model intuition, and all those things. Why? Because at the end of the day, we are actually addressing some problem here, whatever the problem is. Right? And once we do that, then we go to the third step, which actually tells you, okay, test the model. So basically, you gather the relevant information about the variables, and you want to know whether they are positively associated or there is a causal relationship between the variables, so on. This is called the empirical part. Is that clear? For example, I want to ask, what causes GDP growth? Can anyone tell me what causes GDP growth? Sorry? Consumption. What else? Sorry? Okay. Now, here's the problem. When I do that, I don't actually get, let me check. So tell me, which screen is on? That is screen, right? No. This is the one. Okay, that screen is on as well. So I want to minimize that thing. So let me check. I need to show you some article. I'm not sure where I put that article, but this is not the article that is on. So go on. So you says that what causes the GDP growth rate? Again, what's your answer? One says consumption. Is it true? Export. And government spending. So these are all relevant variables, right? So what you need to do, you need to collect the data about these relevant variables, and then you do what? Run a regression, look at whether they have any relationship with the GDP growth rate and export, GDP growth rate, consumption, GDP growth rate, whatever variables you think is suitable, right? I'm going to put an example. There's a bunch of economists. They think in a very weird way. And now I'm going to show you what they're thinking of. But before that, I need to take this screen off for a moment. How do I take this screen off? But when I do that, it all goes away. I don't know why. Sorry about that. Let me check whether I can get it from here. Is the right one that I'm doing? Yes. There should be some way that where you cannot see the display, right? But don't feel offended. Okay, this is the one I was looking for. Let me check whether it's opening. Oh, it's opening. So I'll just show you how the economists think. What is the title of these things? They're talking about the economic growth, but unlike you, they've identified something else. Now, these are the economists, bunch of the economists who actually did that, and they are asking a question whether the mail organ and economic growth, are there any causal relationship between these two or not? Unfortunately, they find the answer is yes. Now, here's the abstract. Look at this, what this says. The study explores the link between economic growth and panel length between 1960 and 1985. It estimates an augmented Solow growth model. So basically, Robert Solow, who actually develops the growth model, and later on, he got the Nobel Prize for that. It's a very well-established growth model. Now, there's another thing, Mankiw, Romer, and Will. They also did that thing. Now, remember, the Mankiw book, the macro that we are covering is coming from your Mankiw book, right? So here's the one. Look at this, what this says. Economic development between 1960 and 1985 is negatively associated with the size of male organ, with considerable reservation it also to type, right? Now, more importantly, the size of male organ is found to have an inverse U-shaped relationship with the level of GDP in 1985. And now you can see that despite the robust, so basically the last line, what is it? The link between panel length, testosterone risk-taking, and self-estimate production, despite the robust statistical links, until more rigorous treatment on the subject of the proposed male organ hypothesis should be taken with reservation. Even though they says it should be reservation, but they find the robust relationship. And more importantly, they find that the government policy is not that effective when you consider this male organ size. Now you see, they completely think in a different way. Now, when I say that, these economists, what they did, they produced this thing. Now, look at this, how they work. So basically, they try to identify the theory. So here, they talk about the Mankiw's theory. They talk about the Summers and Houston theory. These are very famous theory, right? And finally, they gather the data. So this is our last step, right? When they gather the data, they actually do this regression, the variables thing, and eventually, this is the regression line they estimate. We will cover that thing in the econometrics case, right? Applied statistics. And finally, when they run these things, the result is coming in this way. So this is the inverse U-shape. So here they're talking about the size of the male organ in the horizontal axis, and here they're talking about the GDP. And initially, when the size is low, the GDP growth is low, is medium, is the maximum. As the bigger, then GDP growth actually dive down, right? So this is the hypothesis they're talking about. Now, my intention here not to go through this paper, but I'm telling you how the economists think. So think big, open up your eyes. Just don't look at your textbook. First, if they ask you a question, try to understand what these questions are, what will be the relevant variables. When you give me the consumption, export, and all those things, I expect that answers because this is how you're programmed when you read the economist's textbook. But these are two well-known economists. Look what they did. They completely go outside of the box. They're asking a question, is there anything else that also affects GDP growth rate, or at least they can predict the GDP growth, and the answer is yes. Here's their findings. Clear? Later on, you'll find a lot of other examples that I'm going to put, right? And you'll be pretty amazed when this thing happens. Okay, so now we know so any question about this one? I already explained how they think. I also give an example how they think actually, right? Please don't be offended about this example. These are the articles, research article, right? Land, labor, capital. So basically when you talk about the resources, right, we also actually talk about these four things. So in economics, we classify resources under four categories. One is land. Now, the land generally does not mean just a piece of land, right? It basically means anything that comes from the land. That involves the mining product, the gift of nature, whatever you have, right? These are coming from the land. And the labor, of course, the time allocated for producing goods. So basically, it's the worker's time, the effort that you are providing. And then the capital, you have a physical capital, which is the technology, right? And what else? You have also the human capital, which is basically the skill like engineers, scientists. These are the human capital. Finally, you have an entrepreneurship. Now, in economics, we also call entrepreneurship is a resource. Anything that we say resource, always remember we have a limited resource. Basically, we have a scarcity of resources. Now, how does that entrepreneurship becomes a resource? Of course, if you have heard, what is the Microsoft founder? Bill Gates? Everyone knows that? He's an entrepreneur. The Harvard dropout student, and look what he builds. The entrepreneurship needs innovativeness. And that innovativeness itself is scarce, right? If you put me in his place, I will never come up with that, right? Because I'm not that innovative. Do you understand? So that's why we call entrepreneurship itself is a resources. And what does the entrepreneur does? He actually combines land, labor, capital, and his innovativeness to come up with a new thing. Clear? So that's what the thing is. Now, I just captured the basic understanding of the economics. Now, I have to go through the technical aspect. But before we go to the technical aspect, what do you think? Should I take a break? Because I need your full attention on this, because these are the building blocks. Now it's time to get serious. When I say get serious, really, really serious, I need to make sure that your neuron cells are now very productive for next 20 or 30 minutes. Because once you understand these building blocks, I can assure you next 11 weeks, everything is done. Finish. You will understand very quickly, right? So take a quick break for 1 hour. And then we'll come back, okay? Sorry, not 1 hour. I was thinking something else. Take a quick break for 10 minutes. We are going for building block, the technical aspect. Now, in this part, I really want you to focus, right? Because if you really understand this, then you find the rest of the 11 weeks will be very good. Now I will show you what I do. Generally, as I said, I hate one thing in this lecture class, to go with my slides. I absolutely hate it. Having said that, I apologize because I have to follow it so that everyone knows what I'm talking about, right? But very often you'll find me, I'm writing. I'm giving you some information. If you can, please take note. Right? Because at some point of time, you'll realize those are lifesaver. Right? Okay. So let's start with that. The first thing that you need to know is the very first thing, slope. Right? It is called a slope. So what does that slope means? Why is it important? Can anyone tell me? Okay, now my off-campus student can't hear you, so I have to repeat it from now on, right? Whatever you said. So the one student, what's your name? Al? Okay, he says that is a ratio. Which is correct, because if you look at the definition of the slope, it is over something. Vertical run over the horizontal run. So immediately that comes to my mind, it is a ratio. Whether it's a proper fraction, improper fraction, it doesn't matter. As long as there's a fraction or ratio, it will be there. But my intention is not that. My intention is, what is slope for and why we are interested in slope? More importantly, idea about the trends. Excellent. So what's your name again? Shalu? Okay, she says that it gives you the trend or idea about the trend. Now let's create an example to understand. Whenever someone says slope, forget about the definition of this one. It's very confusing, right? I don't want to go through that thing. I want to know what is this slope means. Okay, now, I don't get these things, but okay. Tell me, what will be the slope of the surface of this table? The table here, where my computers are, and I'm asking you, what will be the slope of the surface? This is the surface area, surface of this table. Immediately, some of the students say 0. Any other? ideas? In the natural numbers, there's a lot of numbers, 0, 1, 2, 3, you can go up to infinity, right? Now, any other ideas? Is it 0 or something else?
So 1.
Oh, he got 1. Okay. So now I got 0 and 1. Any other idea? Hey, you can pick any numbers, right? But which will be likely 1? Now, if you really want to know what the slope is, forget about this definition. As I said, I'm going to use a primary school maths understanding, not this kind of understanding. This is a slope. Put a round-shaped thing on this. My pen, the marker pen, does it look like a round shape? This way? I put it in here. Does it go anywhere? This round shape, when I put my round shaped pen on the surface of this table, is not moving any direction, provided that I control all the friction and everything, right? Those remain constant. So it's not moving in this way, not moving in that way. That basically means the surface is pretty flat. When any surface that you consider which is pretty flat, right? Always remember the slope is 0. Don't go for 1. Don't go for 2 or any other numbers. Put it another way, if you put a round-shaped ball on the surface and this ball start moving in the falling down or going up or whatever is happening there, whatever it is, slope is not 0. Now I show you why. This is my paper. I put the same paper on the surface, right? Now look at this. The corner of this table, I call it point of origin. What does that mean? My reference point. Anything that you want to compare, you always need a reference point to compare, right? Otherwise you cannot compare. So now it's coming to the comparison, and I call this point, the corner of this table, that's my referencing point. Sometimes we call it point of origin in mathematics, but I will probably call it referencing point, and I consider that's a 0, right? I put this round-shaped thing here on here. It's not moving anywhere, right? Now look what I'm doing. I'm doing one more thing. This end, I put it as it is, but I lift up this side in this way. Clear? Now tell me, is that slope is 0 or something else? I can check that. I put this pen here, and look, it's rolling down. So that basically means slope is not 0 anymore. The surface is not flat. Why? Because this pen is sliding down. So there's something is changed here. What is change? What changes occur in this case? Look at carefully. The horizontal distance is still the same. Remember I fixed this end? It is the vertical distance. Why? Because when I put it down, the vertical distance with this table is 0. As I lift it up, I'm actually increasing the vertical distance here, right? The more and more I lift it up, the surface becomes steeper and steeper, right? And at one point, it becomes vertical. Clear? So clearly, this experiment actually tells me a couple of things. One, what is your horizontal distance? And if you fix your horizontal distance, then it also depends on your vertical distance, because when you lift it up, you actually create an angle, the surface, with that table surface. Can you see that? This is the angle. How do we measure that angle? That's the slope, the definition. Look at this. It says horizontal distance, you require vertical distance, and more importantly, it is the vertical run. When I say run, it also means distance, right? Vertical run over the horizontal run. So basically, if this is your horizontal run, this is your vertical run, that ratio actually tells you this angle of this one. Clear? Those who are my off-campus students, I'm really sorry because there's no camera, so you can't see it, but now I'm going to draw the picture so that you understand what I'm talking about. So to do that, I'll go with my dock cam, right? I'll put the dock cam in both sides, so in case. And Could you please make sure that you can see my paper? Is the paper is visible at the moment behind my back? Okay. I'm looking for my pen. Got it. Before I start, I need to tell you something, right? I have some physical limitation. What is that? Sometimes I say something, right? It doesn't make any sense. Basically, I'm gibberishing, right? And sometimes I speak too fast to follow. The thing is, when I was a kid, my dad and mom both are medical doctors. At that time, we are in the Europe, and I was with speech therapist because I couldn't talk properly, right? So now I learned to talk, but sometimes it goes too fast and sometimes it's gibberishing. When this thing happens, I apologize in advance because that's my limitation. Please feel free to stop me, and then I can go it again. Now, believe me, when I do that, basically I'm thinking something else, or I'll be very excited and then going that way, right? Even my mom doesn't understand what I say. If my mom doesn't understand, nobody in this class will understand. That I can tell, right? So when this thing happens, please feel free to stop me. And just tell me, Nobin, can you say it again? Then I will understand that I'm not in good shape, right? So I will go through slowly. Just aware of that. Now, for my on-campus student, so here's the slope. So can you see that when I write down? So I'm talking about slope, right? So what I'm saying here, suppose this is the point of origin, right? That is my referencing point, and I put a round-shaped ball on the surface of this. If it's a round-shaped ball, you'll find that it is not moving any direction, provided that everything else remains the same, right? That basically means the surface of this surface of this one is completely flat, and we call the slope of this line is 0 because it's a flat surface. Now suppose I fix up the distance of this. In this distance, I'm not doing anything. But what do I do? This one, I'm lifting up in this direction and see what happens. So if I do that, then pretty much, because this is fixed, it looks like this. Because I'm lifting it up in this direction, right? Now, if you put the same round-shaped ball in here, what will happen? It slides down. Again, I assume that gravitational force and everything remains the same, right? So if you look at the picture, this picture and this picture, something has changed. What is that? Still, we have the same horizontal distance. We call it horizontal run. So say 0 and I call it x. So this is your horizontal run, I call it HR, right? Still it is the same. And here, the same distance we have, horizontal run, but here the vertical run is 0. There's no vertical run here, right? But here, when I lift it up, I actually create a vertical run, which is this, right? Because I'm creating that, that's why I'm getting an angle, this angle. And what is the angle? The angle with my surface. Now, if you look carefully, close observation tells me this angle can be measured because I lifted up the vertical run upward, at the same time the horizontal run, right? So now I will say the slope is nothing but your vertical run over the horizontal run. Is that clear? Do you understand this? Basically, this is the angle I'm trying to measure. Clear? Now, those who are really good at maths, right? Now, I need to go a little bit. If you are really good at maths and you remember still grade 10 maths, we are talking about gradient. And if you're really good at maths in a sense that you understand trigonometry, we are talking about theta, and you have to take 10 theta. That's the slope. Now I go even more advanced. If you really want to know, or actually know the calculus, then I'm talking about derivative of y with respect to x, dy dx. That's the slope. And those who are like me, forget about all of this. We are talking about vertical run over the horizontal run. Why? Because we are talking about this one, and this one tells you the horizontal run and the vertical run. Now think about this way. If I lift up more, so my vertical run like this, which one is steeper? This one or this one? Let's call this line A, line B. Which one is more steeper? B. Why? Because it has more vertical run. Even though it has the same horizontal run, but vertical run is higher. So if the ratio is this, and your horizontal run remains the same, but the vertical run goes up, that is the numerator value goes up, obviously the value of the ratio will go up. This is exactly the reason the slope of B line is steeper than the slope of A line. Does it make sense? I'm not using any calculus here, right? Now, the question remains, why I need to know that? Okay, we are not sliding down, right? We are not skating in the skate park. Why we need to know the slope? What is the rationale? Why in economics? Okay, if it's a physics, I understand why we need it, but why in economics? Yeah.
To know the opportunity cost. Because by this we will be knowing that what will be the best option for us. And then after it, what will
You don't need to stand up. See, be comfortable, right? As I said, I'm not doing any formal thing here. I like informal. Come to me. If you have any question, throw me a question. No formality. So he actually says that we need to learn what? Opportunity cost. That's why we need that. Really? That's the only variable. I will say, yes, you're partially right, right? Okay, I'll come back to that one. But more importantly, when you say slope, right? Now I need to go back a little bit what it means. This time, I'm not going to put this example, rather than I put some numbers and see what does that mean. So what I'm going to do here is as follows. So in mathematics, sometimes we call it axis, right? This is x-axis. You can call some other axis. The x-axis, we put some variable, basically independent variable. This is the y-axis, right? Now remember, this axis has got a 4 quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Mostly in economics, you'll find that we are using quadrant 1, so don't worry about quadrant 4 or quadrant 3 or quadrant 2. Why is that? Because anything that you show in the quadrant 1, all the variables are positive. Now the question is, you can ask me, Nobin, what does that mean? Okay, here's an example. I go to the supermarket, I buy a 5 kilo bag of apple, I love apple, and then I say, okay, I'm going to give you minus $10. What is the shop? I mean, whoever in the retailer or wants to take the cash, what will be her reaction or his reaction? Minus $10, what does that mean? For the first thing, she will say, you are joking. You must be kidding. Then if I insist, no, I'm telling you the truth. I'm giving you minus $10. Probably she will say, Nobin is insane. The thing is, price cannot be negative. If it becomes negative, what does that mean? You take the apple, 5 kilo bag, and you are paying minus $10. So basically, you are taking $10 as well. So I'm giving you a product and the price. Doesn't make any sense. Do you understand? So that's why in economics, we always consider the quadrant 1. Because in economics, most of the variables that we work with, price, quantity, in particularly in the market, they cannot be negative. If I go to the market and say, hey, give me a minus 5 kilo bag of potatoes, everyone will say, oh, okay, nobody needs to go to the mental hospital now. Right? This is the reason we always do that. That's the first step, right? Now I'm going to put some numbers. So as I say, point of origin is 0. This one is 10. This one is, say, 5. Now I connect that, and this becomes my straight line. Right? Now, you can ask me, Nobin, why you consider a straight line? Why not some curvature? Wiggly shaped curvature. The thing is, generally, we start with the simple thing. If we understand the simple thing, then that simple thing can help us to understand the complex thing. And mathematician loves to do that. They never start with a complicated thing. Even though you give a complicated problem, they always simplify it in a very simple problem. They try to understand how these things work, and then based on that, now they add it up together to address the complicated problem. The same intuition in economics as well. Even though you give us a macro problem, we always go back to micro. We try to understand how the micro level, how does that work? Later on, we try to aggregate all of them together. Then we say, okay, let's see what happens to the bigger picture. Right? For that reason, economics is also known as a science. But if you understand, it's not just economics, sociology, psychology, you always find they do the same thing. Even the management, they do the same thing. Right? Suppose you understand how the organization behaves. The behavioral organization, right, which is a part of the management. You start with a very simple problem. Try to understand how the one simple organization behaves. Later on, you expand it to understand the complex behavior of the organization. Clear? This is exactly what we are trying to do. Instead of start with the curvature thing, we start with the simple line, because a straight line is a very simple thing to work with, right? Now, I want to know what the slope is here. By definition, I know the vertical run, so when I write VR, remember, this is a vertical run. Sometimes we call it vertical distance, and this is a horizontal run. Right? Now, I need to find out the ratio of that. So look at this, how I calculate. So the vertical run, it starts from 0, end up with 5. So what is the difference? My primary math tells me the vertical run, the distance will be 5, take away 0 is 5. Right? Then my horizontal run, again, it starts with 0, end up with 10. So what is the horizontal run here? 10, take away 0, that will be 10. Clear? So what will be the slope here? Well, my slope is vertical run over the horizontal run. So basically what it means, 5 over 10, so the slope will be half. Is that clear? Anyone here who doesn't understand this? Everyone understand that part? Simple? Now I'm trying to get it generalization. Generalization in a sense, try to make it more general. Rather than choosing a number 5, 10, can we make it general? The answer is yes. Let's call this 5 is y2. Just a symbol, I just denoted 5 is my y2 here. Nothing has changed, right? This 10 is my x2. I just rename it from 10 to x2. There's no problem. As long as I'm, say, for example, my name is Nobin, you can call me something else, right? XYZ, but that doesn't change the fact I still am the same person, right? So all I'm saying, that 10, instead of saying 10, let's call it x2. Instead of call that 5, let's call it y2, right? And this one, let's call it y0, and if it's x, then let's call it x0, right? Then when you talk about the vertical run, what you are essentially doing, y2 minus y0, am I right? That's what you're doing, right? And when you take the horizontal run, basically what you're doing, x2 minus x0. Clear? Now I put it again, so basically the slope, that means vertical run over the horizontal run, which means y2 minus y0 divided by x2 minus x0. Nothing has changed. I simply change the name. That doesn't change the fact it is still the same distance. Clear? When someone writes y2 minus y0, what does that mean? Initially it was 0, then it goes to 5, and you take the difference between 5 and 0, you actually end up with the 5, but basically you are talking about the change in y. Why? Because y actually measures the vertical distance. When you take the change in y, that much distance it has changed, right? So sometimes that y2, y0, we call it change in y. Now this later is Greek delta, capital delta. In mathematics, it is norms to say it means change in y. Is that clear? So those who don't know what the delta implies here, change in the variable which we are interested in. Clear? Okay. Similarly, this delta x, basically x to x minus, that we call it delta x, change in x, right? Then by definition, the slope is nothing but change in y over change in x. You got it? Now I'm trying to understand, what does that mean now? That's the part I want to know. So basically, I simply rename it, make it more abstract or general. When I say vertical distance, basically I want to know the change in y, because y measures the vertical distance. So I want to know how much vertical distance has changed. When I say horizontal distance, because I'm showing the horizontal distance in the x-axis, so I want to know how much change occurs in the horizontal distance, right? Now, when I take the change in y over change in x, what does that mean? Basically, it means rate of change with respect to x. Can you understand that? What does the ratio means? Say, for example, if I have, how do I say that? Okay, the total quantity of apple that I consume is 20, right? Okay, and I want to divide that thing, the number of person, each person get one apple. So the number of person is 20 as well, right? So one person will get how much on average? How do you get it? Quantity A over n, that will be 20 over 20, that will be 1. But how do you interpret it? The one that you show in the denominator, which is the number of the person. So basically you can say this is apple per person. Can I write in that way? So in other words, what you are saying here, the same intuition, it is the change in y per additional change in x. So what does that mean? If your x changed by little bit, how much y will change? Right? That is nothing but the slope. In other words, this is the rate of change basically. Rate of change of y with respect to x. Clear? That's the part the economists are interested. Economists doesn't care the slope, okay, these are science stuff. I don't care. But when I say rate of change, oh yeah, now you draw my attention. Why? Suppose house price at the moment in Melbourne, right? Say for example, the price is 10. Say, whatever the house price is. I want to know what will happen after 5 years. Why? Because I'm a potential real estate investor, right? As a realtor, I want to know how much money I can make. Now that actually tells me I need to know the rate of change of the price per year. That means the slope, right? If I know how the rate of change in the price occurs, then I can predict what will happen at 5 years period. And if I know what will happen in the 5 years period, then I can see whether my money, if I invest right now, the 5 years it will go up or go down. And that helps me to make my investment decision. Clear? This is why we need a slope. So I start with a very simple example, then I go with the numbers, then I generalize, and then I show you actually the slope is nothing but the rate of change. And then I say, okay, the economists are interested on that. Because if you know the rate of change, then you can forecast what will happen in future. Does it make sense? That's why you need. So if you go to the RBA website, you always find they actually forecasting. You see, they forecast about the housing price, they forecast about the interest rate and all those things. Basically, they are giving you information about the rate of change and all those things. And once you know the rate of change, then you can calculate using that rate of change. Now you know how to calculate the rate of change. Basically, you have to take the slope value, right? In the regression analysis, which is in the week 10, we'll again discuss about the slope and how to estimate that, right? Once you know that, you actually take that information and make your own investment decision. Okay, this is the rate of change. If I invest my money, what will happen in future? Does it make sense? Okay. Any question? Are you comfortable with the math that I'm using? Everyone is comfortable? This is what I'm talking about. Okay. Now let's see how far I have covered. So the horizontal line, now basically this is the slope. Now do you understand this bit? I'm lifting up the horizontal line and then I'm showing you how this is different. Now this part actually you need to understand this bit, x and y positively and all those things. But before that, as I said, I'm going in my way, right? And go back to that thing again. So go back to DocCam again. So this is page 1. Hey, by the way, what happens, majority of my students, from my experience in the previous semesters, they like my handout, right? Because they think it's very much easier to understand. So do you want me to scan it and upload in Cloud Decking so that you can know what I'm doing? So I'll do that thing, right? So don't take these pages, because what happens last semester, everyone's taking my pages and I have no pages, right, to upload. So please don't do that. Be patient. I will scan it and upload on the Cloud Deck, and so everyone knows what is happening, right? And I shall upload it on the week 1 lecture. So I have a week 1 folder. You find there's a lecture notes, there's a problem set, and then I will say Nobin's handout. What it means is my handwriting, basically. Okay. So this is the page 1. Now I'm going to show you what is the relationship means. Now that we know, can you see the slope? Okay. The important part is this slope can be positive, right? Or it can be negative. We also know it can be 0 and it can be infinity as well, right? And it lies between 0 and infinity. Clear? Now I need to know, what does that mean? Are you familiar with the enemy relationship between two persons? What does that mean? There's a two person, A and B, and they are enemy to each other. So if A say yes, what would B will say? No, right? Because he's the enemy. So whatever A does, B will go completely opposite way, right? That's the enemy relationship. Keep that thing in mind. If one say yes, another will go in the opposite direction, which is no, right? Then comes friendly relationship. What will happen? If A say yes, and his best friend is B, what he will do? Support, or he will go against it? Support? Okay. So what is the difference between the best friend and your friend? One is your best friend, but not all of them are your best friend, and some of them are friends. Yes?
Sometimes my friend might say yes or no, but my best friend will always say yes.
Okay, yes, that's right. So your best friend, no matter what happens, he will support you no matter what, right? Suppose you go to jail because of the petty punishment, and if your best friend is standing by your side, he will go jail with you, and he will say, awesome, right? But your friend will not. So I'm talking about the best friend relationship. So in other words, the best friend relationship comes from the fact when you say yes, your friend will always support and say yes. Clear? Keep that thing in mind. When someone says positive slope, always remember it means the best friend relationship. Right? So there's two things that we have shown. One is the change in x, remember? Another is the change in y. So basically you have two variables, x and y. If I say they have a best friend relationship, that means if x goes up, y will also go up. It will follow. right? If X goes down, Y will also go down. That's the best friend relationship, right? We call it positive relationship. If they are enemy, if X goes up, then Y will go down, and vice versa. Now I'm going to show in terms of graph what does that mean. So this is negative slope, so I call it negative, and this is positive slope. I call it positive. Now remember, here I'm showing X, here I'm showing Y, same X, same Y. Choose any arbitrary point. Suppose I choose X1 here. Given X1, what will happen? The corresponding Y will be Y1, right? For this X1, the corresponding point is here, so that will be your Y1. Now suppose I increase my X from X1 to X2. Look at this, what happens, then my corresponding Y will be this, let's call it Y2. Now look, because my X increases, Y actually goes down. So if one increases, the other one goes in the opposite direction, right? Sometimes we write in this way, when your X goes up, your Y goes down. If that thing happened, this is a negative relationship, enemy relationship, basically. If X says yes, Y will say no, right? Now, the same practice here. For X1, you have Y1, and if X1 goes up to X2, look at this, what happened. Y actually goes up from Y1 to Y2. So if this goes up, that also goes up, right? So in other words, I can write when X goes up, Y also goes up, and vice versa. This is called a positive relationship. This is negative relationship. In other words, the slope here is negative, and the slope here is positive. Clear? Now, how does that interpret in the real world? In the real world, we can interpret in a very simple way. Suppose here Y, instead of Y, I'm showing price. And instead of X, I call it Q, quantity. Then what it means, if my quantity goes up, the only way my quantity goes up if my price goes down. Right? Now, what kind of behavior I'm talking about here? So basically, my price and the quantity, they have a negative relationship. My quantity can only way go up if my price drops, or if my quantity drops, then the only way this will happen if the price goes up. In other words, this is familiar. It sounds like demand. Not supply, the demand for this case. Why? Think about this way. When the price goes up, what will happen? Given my limited income, price goes up means my affordability level goes down. Then obviously I will demand less good. So clearly, price and quantity, they have a negative relationship, given that my income is fixed. Is that clear? So negative slope, really important then. Right? So now if I say house demand, then I can say what will happen if the house price goes up. Because the slope is negative here, which means if the house price goes up, the demand for house actually goes down. That is quantity demand. Does it make sense? What will be the positive one? Again, think about the producer. When the price goes up, then producer realizes if I sell more, I can make more money. So producer has an incentive to produce more output, that is Q. So in other words, Q and price, in this case, is positive relationship. Clear? Now, if the house price goes up, as a seller, I have an incentive to put more houses in the market. Right? But the consumer goes the other way. Clear? So this is an example why this slope, positive slope and negative slope matters. We are talking about the rate of change, but this time we are asking whether the rate of change is negative or the rate of change is positive. If the rate of change is positive, it basically means both variables have a positive relationship. If one goes up, the other will goes up. It's kind of supply curve, because what will happen if the price goes up, producer will supply more to make more money, right? On the other hand, if the rate of change is negative, that's kind of demand curve. Why? Because if the price goes up, your quantity demand decreases. Simply because your affordability level goes down, so you demand less. Clear? So that's why we want to know the rate of change is very important, whether it's a positive or negative. Is that clear? Okay. So I'm not only just giving you these things, I also give you the intuition why it is important. There's also two important cases. One case is this will happen. Another case is this will happen. Now, in this case, we know this is a flat. Remember, if you put a ball here, it will not move anywhere, so the slope will be 0. So in this case, slope is 0, right? In this case, slope will be infinity. Can you see that? Because your vertical distance, there's no end there. You can go up, 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 all the way up. It will never end, right? So therefore, your slope in this case will be infinity. So what does that mean? One thing, here, it doesn't matter what the variable, let's call it Q, whatever the Q is, it doesn't matter, your price remains the same, right? If I consider this level Q, still my price is the same. If I consider this level of P, my price is the same. On the other hand, here, given my Q is fixed, the price can explode to infinity. Again, the question comes, okay, the slope is infinity, here the slope is 0, what is the real world application of that? In the market, one of the important part in the market is whether the firm has a market power. Think about the Microsoft. Do you think Microsoft has a market power? The market power means whether I can change my price. I can make the price. Can the Microsoft do that? They always, because they are the dominant firm. They're the monopolist, right? What do you think that the Microsoft sometimes gives a huge discount on their price? You know, the Microsoft, you want to go for Windows or you want to go for, the MS Office or something. Sometimes they give you 50% discount, sometimes they give you free.
Because the demand is low.
No? Sorry? Yes, what? Say it again. To rule out the competition. That's a very nice answer. The thing is, if I manipulate the price, I know some of the competitors try to enter in the market. And I want to make sure their life will be miserable. Always remember, monopolies do not like to give their market share to someone else. They don't like it. So in that case, they will create havoc or some sort of barrier. The best example, again, is the Microsoft. Now I give you the real world example. So what kind of browser you are using now? Internet Explorer, Mozilla, Safari, Chrome, Google Chrome, right? Long, long time ago, these browsers are not there. At that time, there's a dominant browser. It's called Netscape Navigator. Have you heard that name before? They are the dominant in the browser market, and they control the 80% market share. I'm talking about way back. Microsoft wants to enter in this market. Do you know what they did? They have their own browser. They call it Internet Explorer 4.0, right? And they want to enter in this market, but the Netscape Navigator already got 80% market share. So what they did, they produced a threat to all those computer manufacturers. What is that? Okay, you're using my Windows operating system, excellent, fine. And I'm giving you Internet Explorer, free. No charge, free. But you have to install Internet Explorer with the Windows. All the computer manufacturer says, look, Netscape Navigator is very popular at the moment. Right? Consumers love that. So why I'm going to do that? And they says, well, if you don't like that, we have a good answer for you. We are going to terminate our license of the Windows operating system with you. Take it or leave it. Now, this is the aggressive monopolist behavior. I'm giving you free, and at the same time, I'm making a threat. If you don't take that free stuff, then I'm going to terminate my license. Now, by then, majority of the people are using Windows operating system, right? Because it's graphical interface and it was very popular. So if they terminate, then all the consumers will be in big problem. The computer manufacturer knows that, so they have no choice but to install Internet Explorer. Do you understand how they enter? Guess what? Netscape Navigator took the Microsoft to the Federal Court of Justice in US because this is called anti-competitive behavior. They did that. It took 5 years. And finally, the Federal Court of Justice said, okay, Microsoft did something wrong. This is anti-competitive behavior, so they fined it some $1 million. Right? Microsoft knew that. They know this will take 5 years. That's fine. I have $1 million budget to pay the fine. That is also fine. But guess what? After 5 years, what happened? Netscape Navigator, their market share drops from 80% to 30%. Internet Explorer, their market share goes up from 0 to 70%. So what the monopolist did here? It gives you free, right? And because of that free and also produce threat, now they captured the whole market. Even though they pay $1 million of fine, they don't care because market is mine now. Did you see how aggressive they are? When this will happen? When the firm got a market power. Now remember, when the slope is 0, that means your demand curve, that is price and quantity, is such that no matter what quantity you choose, your slope will be, price will always remain the same. It also implies that you have no market power. So that gives a valuable information to us. So when you have a quantity demand and you have a price and then you find that the slope, that is rate of change, is equal to 0, that also means whoever produced this quantity, they have no market power. But if if the slope is not 0, right, either is like this, it means they have a market power. Clear? So monopoly faces this demand. Which market faces this demand curve? Competitive market. For example, the dairy product, right? Whether you go to the big shop like Coles, Woolworth, or you go to the local grocery, you'll find the dairy product price is pretty much same. Maybe it's a difference 20 cents or 10 cents, right? But almost in general, they're very close. Have you noticed? That also means the dairy product farm, the rate of change is pretty much 0, which means the demand slope is 0. They have no market power. Market power means as an individual dairy farm, I cannot manipulate the price. But the monopoly, the rate of change of the slope is not 0. It will be like this. Why? Because they can manipulate the price. Does it make sense now why we consider that? The rate of change is 0 actually gives you valuable information. It basically tells you whether the firm has a market power or not. Does it make sense? Okay. Now, what will be this case? When this will happen, that means your quantity is fixed, but the price explodes to infinity. That means any price you want to charge will be fine. What will be that case? Sorry? Medicine, the life-saving drug. Suppose I got a disease, I got a bacterial infection, and as long as my doctor says, okay, you have to buy an antibiotic, I have no other choice but to buy that and complete my course of drug, right? Those 20 pills or whatever it is, I have to complete that. Now, that basically means that life-saving drug, that's a fixed course that I have to complete, right? So that quantity is fixed, but the price, if as a pharmaceutical firm I know I'm the monopolist, that's you have to come to me, no other choice, then I can charge any price that I like. Can you see that? I don't care what the consumer thinks. If you die or leave, I don't care. I care about my profit. I'm a very cunning producer here. So what I will do? Charge highest price as much as I can and rip off all the consumer surplus. That means consumers benefit. And to survive as a patient, I have to buy for it. Otherwise, I'll be dead. Right? When this will happen, this basically means your demand, the slope, rate of change is infinity. This is one of the reasons, whether you go to the developed country or developing country, all the life-saving drugs are highly regulated by the government. In Australia, we have PBS. They actually regulated that. If you go to the Indian subcontinent or Asian countries, you'll find it is the government who actually regulate. Basically, they subsidize to the consumer. Does it make sense? So now, again, it comes to the point, this rate of change, that is slope, does matter. In one hand, it tells you what is the relationship to the variables. Another hand, when it's zero, that actually tells you the market power to some extent. Another hand, when it's infinity, it actually tells you the farm has a huge market power, so we might need a government intervention provided that this is a necessary goods. Clear? This is why we focus so much on rate of change or the slope. How does that sound? It gives you a lot of information now why it is so important. Okay? Now go back to our slides. Now remember, the first lecture class, I go very slowly because I want to make sure that you really understand those concepts. Right? So don't worry about that thing. Eventually, I will make it out. So first lecture class, I might not cover everything. But I want to make sure that you are okay with this concept because these are the building blocks. Now you know what the rate of change is. Right? The later on, I will not ask you or say what is the rate of change. I simply say this is the slope. Now remember all those information. There's one more information that I need to know. I need to tell you. But before that, so you understand this positive slope, negative slope, infinity slope and zero slope. You also understand the consequences of this in the market. What does that mean? And when this will happen, right? Okay. Now, I'm coming back to that. Look at this. Slope is delta y over delta x. You know what does that mean? Rate of change in y with respect to rate of change in x, right? So I also explained that. And before that, look at this. If x goes up, y goes up. Obviously, this is a best friend relationship. That's positively slope. Another hand, x goes up, y goes down. Again, that's a negative relationship. And in some cases, when slope is zero, it doesn't matter which way that goes up or down. It will not change. And infinity, it will go to infinity. Right? I not only explain that, I also give you a real-world example. What does that mean and what information it provides us? Clear? Okay. Now, I need to talk about this. The curvature. As I said, we start with this straight line. Still, I need to go through a couple of the points of the straight line. So this is your page 2. So when I say slope 0, I'll just write it down, market power, so that you know what does that mean. This basically means, for example, the life-saving drug, that example I give you. So you will understand what does that mean. And this is a supply curve. And this is the demand curve that I give you an example, right? Now, a couple of things that I have to go with this straight line. Some of the beauties. So now that we know this straight line, we know the slope, the rate of change and all those things. But now I want to know why we use a straight line. There are some beauties of this straight line. Here's the one beauty. If you have a straight line, and you are trying to measure the slope of this angle, you already know the slope of this angle, which is vertical run over the horizontal run. How does that measure? Delta y over delta x, we know that. So this is x, this is y, and we know the slope is this, right? Now I'm going to say one of the simplicity of this one. Suppose I consider this point A, and then I consider this point B. Tell me what will be the slope of A and what will be the slope of B. What will be the slope of A and slope of B? Some says it will be the same. Sorry? Y1, X1 for B. The answer will be, it will be same. Why? I'll show you from the graph. Whether you choose A or B, they lie on the same line. And the angle remains the same, which is x. So it doesn't matter whether you choose A or you choose B, because it measures the same angle, the slope of A must be equal to slope of B. Can you see that from the graph? You don't need any maths for that. So it doesn't matter whether I consider B or A, both lines on the same line. And that line creates an angle which is the same angle x. So what it means, the slope of B must be equal to slope of A. Now, if you want to draw those definitions, the vertical run of the horizontal run, you just draw a vertical line here, then this is your vertical run over the horizontal run, right? And if you draw here, then you will find that this is the vertical run over this is horizontal run. So what does that mean? Suppose this will be, how do I say, that this could be 5 and this could be 10. So 5 and 10, that will be half. Now this could be 10 and that could be 20, but still the ratio is half. Can you see that? So if I go for A, the ratio could be 5 over 10, which is half, which is the slope. If I go B, the ratio will be 10 over 20, but still that's half. The reason behind that, both of the line lies on the same straight line and they measure the same angle, right? That is one of the beauty. As long as you consider the straight line, it doesn't matter which point you consider on the straight line, every point on that straight line always gives you the same slope. In other words, in economist terms, we always say that linear or the straight line always give you the constant rate of change. Here, the rate of change is half, and that remains constant for every point on that straight line. Is that clear? Okay, so what I'm saying that as long as the line is a straight line, every point of that straight line reveals the rate of change, which is constant. That basically means slope remains the same. Clear? That's the beauty of the straight line. And when I go for the curvature, I'm going to use that beauty. Now I'm going to show you how. So is that clear now? Okay. Suppose I have a curvature which looks like this. Right? Now look at this. I want to know what will be the slope at point A. That's my point of interest. I want to know what will be the slope at point A. The problem is, my naked eye observation tells me this is not a straight line. That's the first thing. When you want to solve the problem, always remember, if you want to solve the problem, the first thing you need to know, what are the things that I know that can help me to sort out the problem. So at this stage, I'm recalling what are the things that I know. I realize the only thing that I know is the straight line. And I know the slope of this straight line, and I also know every point of this straight line gives you the same slope. Right? The second thing is, that part I know. Can I use that part to answer my question, that is the find out the slope of A on that curvature line? If I say yes, I solve the problem. If I say no, then I go back again and find out what are the relevant information that I have to know. Now, for luckily, in this case, the answer is yes. You can use this straight line property to find out the slope. Now, to do that, remember, I want to know the slope of point A, not any other points except A. So, can I use this straight line? The answer is yes. I can draw a tangent line. So, what is the tangent line? I draw a straight line that will touch only the point A, but not any other point. Right? So let's draw that line. So in that case, that is the straight line it looks like. That straight line touches only that point, right? Now I extend that thing, and this straight line, let's call that a straight line LL prime. That straight line creates an angle x, right? Now, if I want to find out what will be the slope of this straight line, what is the slope? I know this is the horizontal run, this is the vertical run. Take the ratio, you will get the slope of this. But then I also know any point that lies on the straight line gives you the same slope. That basically means that point A that not only lies on the curvature, but remember how I draw the line? It also lies on this straight line. So whatever the slope of this straight line is, the point A has the same slope. Do you understand why I did that? It's a very simple problem that I know before, and I don't want to know anything else, just use that. Now, if I ask you, okay, what will be the slope at point B? I use the same technique, draw a tangent line that goes with point B. And when I go with the point B, that tangent line will be this. Right? Clearly, I can see that at point B, this line is steeper than that. So that basically means when I move from A to B, my slope actually increases. Can you see that? So this one is flatter. I'm not sure what I'm writing, and this one is steeper. So basically, my slope is getting steeper here. Simply because my line, straight line, is lifting up, is pivoting in upwards way. This is called pivoting. It's pivoting in this way, which means your vertical distance actually goes up. Remember what I said? If your vertical distance goes up, pretty good, you end up with the steeper thing, provided that your horizontal distance does not change that much. Right? Now, that's the end of the story. Now we know how to find out the slope of a curvature line. Does it make sense? You just know the straight line, shift all the knowledge here, do that thing. Very important thing now. Whenever I say slope, this is also known as a marginal thing. Whenever someone says marginal, keep in mind, geometrically, it means slope. So if I say marginal benefit, it means slope of the benefit curve. If I say marginal revenue, it means slope of the revenue curve. If I say marginal, the marginal cost, it means slope of the cost curve. Does it make sense? So in other words, when I say marginal benefit, it also means slope of the benefit curve, also means the rate of change of the benefit with respect to variable that you are considering at the moment, right? So always remember, whenever I say marginal, say benefit, basically what it means, it is the slope of benefit curve. Now it makes sense, right? Now I will show you how does that slope matters. Say for example, I'm plotting my profit, right? The profit, here I'm showing profit, and here I'm showing the output that I'm producing. Oh, sorry. Can you see that? No? So here I'm showing the profit, here I'm showing the output that I'm producing, and I'm asking a question, how much output I will produce? Right? Of course, because I'm making a choice here. And remember, production cost, the more you produce, your cost will go up because your resources are limited, right? So my production cost will go up, so I have to make an efficient choice here. And what is the choice? How much output I will produce. I have noticed that the profit data tells me that initially when you increase your output, your profit goes up, and then it reaches maximum, and then it goes down. Right? So what does that mean? As I produce more and more, initially my profit goes up, and that will be maximum at this point, right? And after that, my profit starts falling. Clear? Now, what will be my optimum point? Which output level should I choose here? Sorry? Pointed where the profit is higher. So which point will be this one? That point? Right? That point my profit is higher, and after that, whether you are here, it will go down, or here, go down. So my naked observation says, remember, the first slide, I say I'm irrational because I'm maximizing profit. So I'm rational, I'm maximizing profit, my desired point is point A. Why? Because at point A, that will give me the highest profit that you have. So let's call it pi h, that is the highest profit you can achieve. Clear? Now I want to know, and the corresponding output level is Q star. That's the output level I have to produce, right? Because that gives me maximum point. That makes me more rational here. Now, I want to know what is the characteristics of the point A. Well, first thing, you need to know what the slope is here, right? In other words, the marginal profit. This is a profit curve, so I want to know the marginal profit, which means slope of the profit curve. So if I want to know the slope, first observation, this is not a straight line. So what I need to do, I need to draw a tangent line through my point of interest. My point of interest is A, right? So if I draw a straight line here, that's the straight line I'm drawing. Clear? If I draw that a straight line, tell me what will be the slope of that line? First thing, slope is 0 because this is a flat. Can you see that? It's a flat. If you put a round shaped ball there, it will not moving anywhere. So my slope is 0. Is that clear? So in other words, your marginal profit, that slope has to be 0. That's called a marginal analysis. But that's not all. I also make sure that this profit is maximized. Now remember why this is not enough. Suppose you cannot visualize the graph. It is also possible that you end up with the graph like this. And in this case, if you are here, what will be the slope of this point? Is also 0. Sometimes slope is equal to 0. This is a marginal benefit or marginal cost, whatever you say. The marginal benefit is 0, that's fine. But it does not ensure you that you are in the top of the hill or you are at the bottom of the hill. Because both of these points give you 0. Look at this. If I'm top of the hill, tangent line is a straight line, flat, 0. If I'm the bottom of the hill, it's still tangent line, slope 0. Right? What do I need to know now? So that basically means the marginal analysis, the first thing, slope will be 0. That will identify the point of interest, but it will not tell you whether you are at the top of the hill or bottom of the hill. Now the question is, if you are maximizing the profit and you are actually having this, then you are the problem because you are actually getting less profit here. On the other hand, you are minimizing the cost, but you actually here, that basically means you are maximizing your cost, which means you are getting very small profit or negative profit there. Right? So now, this is not enough. I have to know more than that. One way to do it, suppose I'm here, then I go a little bit in this case. I move a little bit of the right side of point A. What will happen? So, let's say a little bit right of the point A, that will be point B, right? Draw a slope again at point B. Clearly, I can see that that slope will be negative. Can you see that? Is that negative slope? Remember I told you that downward sloping is negative. On the other hand, same thing here. If I go a little bit right of the point B, look at this. That slope is positive. Now I can do the marginal analysis. So what is that? I have to make sure that my first slope is 0. That actually tells me whether I'm the bottom of the hill or the top of the hill. But still I'm not sure. I just identified my bottom point or top point, but I'm not sure whether I'm the bottom or top, right? To do that, I go a little bit farther right of that point of reference. If my slope is negative, that means now it is definite that I was the bottom of the hill because I'm climbing down now, right? On the other hand, if my slope is positive, that means I was the top of the hill, now I'm climbing down. If my slope is positive, 0 and then positive, that means I'm in the bottom of the hill, now I'm climbing up. Clear? So the first slope, sometimes we call it first order condition, and the second slope, we call it second order condition. So the first slope, the first order condition will be always 0. The second order condition will be negative if you want to maximize something. Maximize means you want to get the top of the hill. If you are on the top of the hill, the first condition slope will be 0, and then you make sure that if you move further right, your slope will be negative. Basically, you are going down. If you are at the bottom of the hill, the first slope is still 0, but if you go a little bit right of that, then you are climbing the hill. Basically, it ensures you are actually bottom of the hill. Right? Now, that's how we need a slope to understand whether we are maximizing the benefit, maximizing the profit, or minimizing the cost. Clear? That slope value actually tells you that. But this time, you have to take two slope values. First, the point of reference, and then slightly right of that point. Clear? We call it first order condition, second order condition. Now, those who are coming from the science background, here's the thing. We are talking about the maximization problem or the minimization problem. If you want to go for maximization problem, we call it necessary condition and sufficient condition. The necessary condition is nothing, dy over dx, and the sufficient condition will be d square x over dy square. Clear? Make sure this is negative. Now, look at the slides now. So I already shown you how to do that, right? Tangent curve. Now, the same way, bowing out or bowing in, it doesn't matter. You just draw a tangent line and you can calculate the slope. But more importantly, look at the maximum point and the minimum point together. So I'm not sure whether I'm going for the bottom hill or the top hill, but you need to draw the slope line. Can you see that M1 and N1 there? But more importantly, this is the one that you need to know, that the first order condition in both case, maximum or minimum, your slope is 0. But the first order condition for the maximum case, your slope is negative. Basically, you're going down, right? That also ensures you are at the top of the hill. But this minimum point, your slope is positive, which basically means you are the bottom of the hill. Now you're climbing up. Clear? That's what we need. Now, after that, how many of you actually understand this? Tell me now. So this is the first order and second order condition, this. Everyone is okay with this? Up to this? Is there any problem? Yeah.
Just to make a clarification, the second order condition is when we go a little right, right?
Because both of them give me 0, whether it's the bottom or the top. So still I'm not sure. 0 gives me I just reached the flat point. But I'm not sure with the bottom flat or the top flat. So now I need to go a little bit right of that point. If I'm climbing down, then I definitely know I was in the top. And if you are climbing up, then I definitely know I was in the bottom. That's the idea, right? The whole thing is also called a marginal analysis. Whenever someone says marginal analysis, as I said, it is nothing but the slope. You are actually looking for the slope value. Now, in one particular case, I show you how the slope value tells you the relationship between two variables. In some cases, I also show you the slope actually tells you whether the farm has a market power or not, right? And in some cases, now I'm showing you the different application of the slope value, which actually tells you whether you are maximizing or minimizing, right? Anyone has any question with this? So far, here's the good news. If you are comfortable with this concept, next 11 weeks, we are not going any new concept. These are your building blocks. So if you are comfortable up to this, next 11 weeks and the final exam, no problem. So whenever, just remember, when I say marginal cost, marginal benefit, it is the slope of the benefit curve, slope of the cost curve. When I say the marginal benefit is positive, then you also know we are talking about the slope value which is positive, basically rate of change is positive. And if I say, okay, they are maximizing the profit, then you know what I mean. If you are the top of the hill, so your first order condition, that is slope is positive, slightly right, slope is negative. That's what it means. If I say, okay, we are minimizing the cost, now minimizing means you are the bottom of the hill, so slope is 0, and slightly right, you're climbing up, so slope is positive. That's what it means. Right? Now, that's the end of the story. I'm not going to tell any new maths concept. This is what you know. So if you are comfortable with this, here's the idea. You will be comfortable with the rest 11 weeks. That includes macro. That also includes the applied statistics or applied econometrics. These are the things what we are going to use. Is that clear? Any problem? Believe me, this actually require year 11, year 12, and in some cases, first year math courses. But I use that, generally we use a heavy calculus to prove that. I use that simply bottom hill, top hill, and climbing up, climbing down. That gives you the same intuition, right? You don't need those sophisticated maths. Now as they come to the production possibility frontier. Before I start with the production possibility frontier, I need to give you some thing. What is the production possibility frontier and why it is so important, right? Think about the real world example. I have a money in my pocket and I want to buy a new medium size of car, or say large size of car, right? What is the configuration that I need to look at first? Everyone has some car, or, you know, I'm not sure everyone has a car or not, but you understand that part, right? So don't go on that side. So suppose I have a budget, I want to buy a car. What are the first configuration, or what are the features that I'm looking for? Sorry? Okay, she says whether it's a sedan or hatchback. Obviously, that's a valid question. Anything else? Fuel efficiency. Well, there's another valid point. Any other thing? Price. Okay. Prices are obviously important because it tells me whether I can afford that thing or not. Yes, very good. Anyone? Sorry? Safety criteria. Yes, that's also a very important feature, right? Sorry? Visual, yes. Whether the car looks really good, right? Color, visual thing. Yeah, yeah. Sorry? Service cost, yes, that will be also important. Yeah, look, you can put a lot of information, but now, so far I know, you forget simple basic thing. What is that? Remember, when I ask you a question, try to understand and then give me a simple answer. And believe me, this world, to give a simple answer is not that easy. When we are kids, we think in a very simple way. As we grow up, we mix up with the grown-up. The thought process are very complicated, and eventually we are in their shoes, so we think in a very complicated way as well. Think in a simple way is the hardest thing that you can do. Look, when I ask you a question, what sort of feature I look? Safety, fuel efficiency, then visual, color, what else? What else you say? Price. You're giving me all those features, but you don't give me the vital thing. What is that? Say, for example, I'm going to buy a Ferrari or Lamborghini, right? I afford that. So it is, generally there's a 5-star safety feature. I will call it 10-star safety feature. So it's the maximum safety feature at the moment. Visually, looks excellent, fabulous, right? Fuel efficiency, oh my God, this is a really good feature there, is excellent fuel efficiency. Service cost is almost 0, right? Except there's one thing. It has an engine size that can produce 0 kilowatt. What does that mean? 0 kilowatt. That means this engine is so fuel efficient. It is fuel efficient because it does not use any petrol, right? Its energy level is 0 at the moment. The thing is, you cannot drive it. It does not produce any energy. So what do you do with this car? Put in your showcase and everyone, hey, look, this is my Lamborghini. There's one problem. You cannot drive the car. Does it help? Whenever you want to buy a car, the first vital information, what is the engine size and how much kilowatt it can produce? That actually tells you how much passengers it can carry, how many things you can tow. If I have safety features and everything is correct, but it has a 0 kilowatt. That means it doesn't produce any energy, it doesn't drive. Does it help? Does it? No. So in other words, the first thing you need to know the engine capacity limit. And every car manufacturer gives you that information. This is the engine size. Given this engine size, this is the maximum capacity limit. Suppose 3.5 liter engine, the maximum it can generate 200 kilowatt. Why this information is vital? As I said, you need to know the capacity limit so that you know how many passengers it can carry, how many things you can tow, and all those things. The other features you say, it will come later. Do you understand this point? Similarly, you might think, oh, Nobin, you are going off the track. Actually, I'm not. When you think about the country, I also know the same thing. What is the country's capacity limit? That basically means, given the resources of the country, what is the maximum amount of output or the combination of output it can produce? That actually tells you the country's capacity limit. That also tells me whether the country is a small country or is a big country. Right? In the real world, how do you know that? When you actually look at the potential GDP. Remember, the real GDP is the GDP that you are producing, but the potential GDP is the capacity limit. Basically, it tells you, given country's resources, what is the maximum amount of output or the combination of outputs you can produce. That's the country's capacity limit. We call it potential GDP. This potential GDP is nothing but also known as a production possibility frontier, PPF. So whenever someone says PPF, always remember, this is nothing but your capacity limit. If I say households PPF, that is households capacity limit. If you aggregate all the resources, that's the maximum they can go, right? And household capacity limit also tells you the maximum purchasing power, right? Similarly, if I say country's PPF, that is the potential GDP, basically says given its resources, that's the maximum amount of output it can produce. Why do you think that US and China, they are the biggest economy in the world? Because if you look at their potential GDP, it will be far, far higher than other countries. Why? Given their resources, that resources, remember those 4 resources, land, labor, capital, and entrepreneurship? Given their resources, what will be the maximum amount of output that can produce? You'll find that China and US, their maximum capacity is much higher than any other country. That's why these 2 countries are the big country. Sometimes we also call them big economic power. Where does that come from? Because their PPF is really, really high. Clear? So that's why we understand or need to understand the PPF. Does it make sense now? You see, sometimes I go off the track, but then I come back, and then you see, actually, these are related to this concept. So next time, when someone says PPF, think about this way. This is your capacity limit. Given your resources, that's the maximum you can do. Clear? Okay. Now, suppose here's the household. What is the household here? Choose any household, Harvey, Barclay, whatever the name of this household, and that's the combination. So this is the piece of land they are using and the working hours. With that piece of land, they can produce either tomatoes or the flowers. But what is the important thing here, this is the maximum capacity they can produce. So if I say, okay, this household will produce the maximum amount of tomatoes. What is the maximum amount of tomatoes they can produce? That's the 3 tomatoes, 0 flowers, right? If I say they want to produce maximum amount of flowers, that's the 6 units of flowers they can produce. But sometimes, you know, in this real world, we need both food and flower. Of course, we go for dating and all those things, we need this flower, right? So that basically means we need both. So then the question is, what is the maximum combination they can produce? You can see that either 1 tomato, 4 flowers, 2 tomatoes, 2 flowers, 3, okay, those are the combination, not the 3. So these are the maximum combination they can produce, right? Now, what we learn from these things, the one thing that we learn, if I want to produce more tomatoes, I cannot produce more flowers. I have to give up the flowers. Can you see that? Suppose you produce 0 tomatoes, in that case you can reach maximum flowers, which is 6. Now from 0 to 1, look at this, my flower production goes down. So in other words, if you want to increase more and more tomato production, the only way you can do it if you reduce the flower production. Why is that? Because your resources are limited. Remember, your piece of land and the working hours, these are limited. So if you want to produce more and more flower, what does that mean? You pull out the resources from the tomato production and you invest in the flower production. When you do that, you should expect your tomato production goes down and flower production goes up, and vice versa, if you go the other way, right? So in other words, what does that mean? Well, we have a trade-off here. What is the trade-off? You cannot have both, maximum. If you want to go for one to increase, the only way you can do it if you reduce the other one. And that's the trade-off to increase flower production or the tomato production. Is that clear? That actually gives me an idea. What does that trade-off means here? This trade-off also means it's called opportunity cost. In order to have one thing, you have to give up something else. Now I'll come back to later that one. So now here's the important part. Look at this straight line. That's the PPF curve. So anything that lies on that point or below that point is achievable because that line tells you your maximum capacity. For example, the point K, it is outside of the line. Can you see the point K? Can you achieve that? The answer is no. Why? Because this is out of your reach. Your maximum capacity is that straight line and the K lies above that straight line. So if you think you will achieve K, I would say you are daydreaming here. That's not possible. The idea is when I say the car 3.5 liter give you 200 kilowatt energy and you say, okay, can I get 250 with this? The answer is no. Because I already give you maximum capacity. No matter what you do, you will never get it. Okay, you can get it if you made a mistake. You don't know how to calculate the kilowatt. Or somehow in the calculation you made a mistake. But in reality, that will never happen. So that's why the K is not attainable. Any point that lies on this PPF curve, we always say efficient. Any point that lies below that line, we say is inefficient. Now we need to know why is that. Can anyone tell me why is that? We know that, but what is the intuition? Now, by this time, you already know how I like, right? So when you give me all the complicated answer, I don't understand what you're talking about. Give me a simple answer so that my 5-year-old kid can understand what you're saying, right? Here's the thing. So this is the PPF curve. I'm going to go back to my doc cam again. Try to understand what's happening here. So this is page 4. This is, which side we are showing what? The vertical axis we are showing flower? Okay, so this is flower and this is tomatoes, right? Now, if you see, I say any point that lies here, we cannot attain that. Why? Because your maximum capacity limit is here. Any point above that, it is out of reach. You can't achieve that. You are basically a daydreamer. Now, any point that lies on here or below here, you can achieve that because that is within reach, your reach. Now, couple of things. Any point that lies on the PPF curve, we always say efficient. It is efficient in a sense you are utilizing all of your resources. That sense. Now I'll show you, in order to explain that, I need to show you first that any point that lies below here, so let's call it Z, is not efficient. If I prove that, then the other one proof is very easy. Suppose at point Z, I'm using that much of tomatoes and I'm producing that much of flowers. Yeah? Point Z, we do that. If I utilize all of resources, then remember, I can increase one of them at the cost of other. If I use all of the resources. Let's fix up the tomatoes here. Can I increase the production of flower without changing the tomato production? The answer is yes. How much? I can go up to here. That much flower production can increase without changing the tomato production. Similarly, if I fix up the flower production F1, I can increase the tomato production up to this without changing the flower production. That basically means when you are at point Z, you're not utilizing all of your resources. Some of the resources kept idle. That's why, without changing one of the production, you can actually increase the other production. Clear? That's why we say point Z is inefficient. It is inefficient in a sense, some of the resources are kept idle. In a sense, you're not utilizing all of your resources, you become lazy, basically. Remember the parent says, lazy thing is not a good thing. That's what is happening here, right? Now, suppose the same argument, now I start with point A and B and see what happens. If I move from point A to B, look what happened. Flower production goes down, then tomato production goes up. What it means, I can increase the tomato production at the cost of flower production, which actually goes down. It also means I'm utilizing all of my resources at full capacity. Only if you do that, that will happen. I already proved that. That is not the case when we operate point Z, right? So that's why we say any point that lies on point A, B, or the straight line of the PPF curve is efficient because you always find that trade-off. If you want to go one thing up, it will come at the cost of other things, which will go down. So as long as you face that trade-off, it also means you are efficient. You are utilizing all of your resources. Remember, the trade-off comes from the fact your resources are limited. So when you increase the flower production, the only way you can do it if you pull out the resources from the tomato production. But pulling out the resources from the tomato production also means your tomato production actually goes down. Right? But if you kept some of the idle, then you fix up your tomato production, you can still increase the flower production. That basically means your tomato production doesn't change, but your flower production increases. It means some of the resources you kept idle. Now you are utilizing all of the resources, so your tomato production remains the same, but the other production actually goes up. Does it make sense? So this is all about the PPF. As I said, PPF tells you the capacity limit. Whether in real world, it's called potential GDP. It helps to understand what the country's capacity limit. For example, in the export market or the international trade, it really matters whether we are dealing with the big country or the small country. Right? Why? Because big country might have a market power. For example, the China. When it comes to the iron ore or the minerals, China is the biggest consumer. 60% of the iron ore is consumed by China, or 70%, which means China has a monopoly power now as a buyer. Why? Because if China says, oh, I'm not going to buy from you, then all other countries who are producing that have a problem. In fact, Japan actually complains that because Japan says, oh, China fixed up the price, so we have no other choice. Japan is selling iron ore to China. Clear? So clearly, you can see that it does matter whether you're dealing with the big country or the small country. A small country capacity limit is low, and they cannot manipulate the price. The big country, their potential GDP or the capacity limit is very high, and they can manipulate the price. Clear? That's the one thing. Okay, now, a couple of things that I need to know. What will be the slope in this case? So let's see what is the slope in this case. Go back to this one. So today I'll just cover up to PPF, then we'll stop. Now look at this. The maximum flowers you can produce 6. Hang on, I'll just come back to that one. And this is 3. Maximum flowers you can produce 6 with 0 tomatoes. 3 tomatoes with 0 flowers, right? So what will be the slope here? The difference is, vertical run, difference is 6 minus 0 will be 6. And the horizontal run, that difference is 3 take away 0, that will be 3. So your slope here is 6 divided by 3, that will be 2. So what does that mean? It basically means if you want to produce 1 unit of tomato, you have to give up 2 units of flowers. So in other words, in this case, slope actually talks about the trade-off now. So in other words, always remember the slope tells you the goods that you are showing in the horizontal axis. In order to produce that good, how much the other goods you are giving up in the PPF curve, right? Now there's another thing. Slope in the PPF curve is nothing but the opportunity cost. So opportunity cost of a good that you are showing in the horizontal axis. That's what it means. So what does that mean? To produce 1 unit of tomato, you are giving up 2 units of flour all the time. Now, to understand that, go back to that table and you'll see that will be always true. Look at this. From 0 unit tomato, you go to 1 unit tomato. How much flour production drops? 2. From 1 unit tomato, you go to 2 units tomato. How much flour production drops? 2. So that basically means for every time you goes up 1 unit of additional tomato, you have to give up 2 units of flours. And if you look at this graph, the 1 point is 6, vertical run is 6, horizontal run is 3, vertical run over the horizontal run 6 over 3, that would be also 2. That basically means slope of the PPF curve actually tells you the trade-off of the goods that you are showing in the horizontal axis. Is that clear? This is also known as opportunity cost as well. Anything? So from next class, we'll start with the opportunity cost and the comparative advantage. So I think we have 1 minute, right? Any question that you have, you can ask me right now. And I'm going to post these things on the week 1, right? Thank you, everyone. So we'll talk about comparative advantage next week.